Hello everyone, I'm Lucas Campos and today we're doing Physics 2212 Lab 3 circuits. So introduction, the purpose of this lab is to analyze how various circuit components function and measure the current and voltage across two circuits that we build. We build a series circuit and another RC circuit. And some of the models and fundamental physics principles is we have energy conservation, Kirchhoff's current law, Ohm's law, V equals IR, and then just some of these like conservation laws and just kind of manipulation of them. So in our first thing, we made a series circuit and we were given in the system a battery and wires and ammeter and resistors. And then to find the current, we had to use this universal, the resistance, we had to use this universal resistance diagram to figure out which one was the 47 ohm and 100 ohm one. And overall, um, the results conservation of current, we predicted that using just the V equals IR, 3 volts over 147 ohms, this would be about 0.024 amps, and the actual is 0.02, and then when it's backwards, negative 0.02 when the current flow is in reverse. And then the voltage at the battery is 3 volts, and voltage at the 47 ohm, 0.95 volts, voltage at the 100 ohm, 1.99 volts. So graphing the potential difference, we see that it comes up, and then over the 47 ohm, it starts to decrease, and then it flattens out, and then it reaches the 100 ohm, and then it fully decreases. So in the RC circuit, um, we 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 filled up a capacitor and then discharged it to see how it reacts with a light bulb. And so the light bulb initially lights up, but gradually dims. This occurs because the capacitor accumulates charge, and as the capacitor charges, the current decreases. And once fully charged, the current stops and the bulb turns off. And then when the circuit operates without a battery and a fully charged capacitor, the capacitor discharges and the stored charge powers the light bulb. So after um like trying the charge and discharge with the different resistors, the 10 ohms, it took 16.45 seconds to charge and 18.12 to discharge, and with the 20 ohm went up all the way to 112 seconds to charge and 63 seconds to discharge. Looking at the results of the lab, so the similarities and differences of the series circuit, the prediction was 0.024 and the actual value is 0.02. Yeah, so there's about 18% difference. And then the voltage measured at both resistors summed up to 2.94 volts, which is a 2% difference from the predicted value of 3 is what it should have been. And then explanation is loop rule. These values work. And then for the capacitor, it took longer to charge and discharge when attached to the bulb of high resistance, and that makes sense because it's the Ohm's law inverse relationship. And some potential sources of error in this lab is the ammeters all sucked and we kept having to replace them. So moving into the further questions, it's what if you charge a capacitor with no resistance in the circuit? How quickly would our ideal model predict the capacitor to reach full charge? Would this prediction happen in real life? Explain. And then we kind of did this out. So with no resistance, the capacitor would just charge instantly. But in real life, that would never happen. There's always going to be some sort of internal resistance, whether it's in the wires or the ammeter's resistance. And also, capacitors have limitations, so they have built-in almost features to not allow it to just instantly charge because that could fry it, or it's like just not good for it as a whole. And that wraps up my lab 3 circuits. Thank you.